this may actually be a piece of alien technology.
Is Earth being watched by something not of this world?
The vast expanse of space holds endless wonders, but also profound mysteries. One such enigma arrived in late 2019, an object designated 3I Atlas. It was a comet, yes, but a very special one, an interstellar visitor, the second ever confirmed. Astronomers eagerly tracked its trajectory, hoping for unprecedented data. Yet, as it approached its closest point to our Sun, something completely unexpected, something truly unprecedented, unfolded. Instead of developing a magnificent tail and becoming brighter, 3I Atlas simply faded into nothingness. The world's largest and most advanced telescopes, the very eyes of humanity on the cosmos, could find no trace. To put it mildly, the biggest telescopes have no clue where it is now, posing a fundamental challenge to our understanding of cometary behavior and interstellar objects. This disappearance is far from ordinary. The astronomical ghost. Initial observations suggested it was a comet, and a rather impressive one at that. As it hurtled through space, approaching our Sun, astronomers predicted it would put on a spectacular show. Comets, as we know, are essentially dirty snowballs. When they get close to a star, the Sun's heat causes their icy components to vaporize, creating a brilliant coma, a fuzzy atmosphere, and often a long glowing tail. Early forecasts for 3I Atlas were nothing short of thrilling. Some models even suggested it could become bright enough to be seen with the naked eye, a truly amazing spectacle for sky gazers around the globe. This was poised to be an astronomical highlight of 2020, a chance to witness a cosmic grand entrance. Imagine, an object from light years away, becoming a beacon in our night sky. The excitement was palpable. Telescopes worldwide, from the mighty Hubble Space Telescope orbiting high above Earth to ground-based behemoths, began to focus their powerful eyes on 3I Atlas. Data streamed in, eagerly analyzed by researchers hoping to unlock secrets about its origins, its composition, and the star system it called home. Every bit of light, every spectral signature, was a clue in this cosmic detective story. This was an opportunity that doesn't come around every day, a chance to touch the interstellar medium, so to speak, right here in our own backyard. For months, it behaved largely as expected, showing signs of activity, growing brighter, and even developing a small tail. The trajectory was mapped with incredible precision, its path taking it closer and closer to the Sun, promising an even grander display. Then, things took a dramatic turn. In early April of 2020, the anticipated celestial show began to unravel in the most baffling way possible. Instead of intensifying its glow, 3I Atlas started to dim, not just a little bit, but rapidly. Images from various telescopes showed not a growing, vibrant comet, but a diffuse, fragmented mess. The nucleus, the solid heart of the comet, appeared to be breaking apart. This was startling, but not entirely unprecedented. Comets can sometimes disintegrate when stressed by the Sun's heat and tidal forces. However, the speed and completeness of 3I Atlas's breakup were extraordinary. Within a matter of days, the once promising comet splintered into dozens of pieces, scattering across several arcseconds of sky. But the real shock came next. As the fragments drifted apart, they too began to vanish. One by one, then collectively, the diffuse remnants of 3I Atlas faded beyond detection. By late April, the interstellar visitor that had promised such a dazzling spectacle was gone. Completely gone. NASA's biggest telescopes, including the Hubble and the powerful ground-based observatories, could no longer find even the faintest whisper of its presence. It had simply gone dark. This isn't just a case of a comet breaking up and dispersing. It's a profound disappearance, a celestial vanishing act that left scientists absolutely flabbergasted. The most shocking fact is that a body of its initial size, perhaps a few miles across, shouldn't just cease to exist so entirely. This unprecedented event challenges our fundamental understanding of cometary resilience and what happens when an interstellar object meets our Sun. Many people are crazy about finding definitive answers, but for 3I Atlas, those answers remain stubbornly out of reach. we were left with an empty void and a truly cosmic riddle. What force could have erased 3I Atlas so utterly from the cosmic stage? A disintegrating mystery. The disintegration of 3I Atlas was far from a typical cometary demise. You see, while comets often shed material, a complete fragmentation and disappearance on this scale is incredibly rare. The thing nobody tells you is that astronomers had expected some mass loss, but not this total erasure. One of the leading theories, a primary suspect in this cosmic whodunit, points to the intense forces exerted by our Sun. As 3I Atlas journeyed closer to the solar inferno, it experienced increasing thermal stress. The nucleus, likely composed of a mix of ice, dust, and rock, began to heat up rapidly. This heating can cause trapped gases within the comet's interior to expand, building up pressure until the structure can no longer hold together. Imagine a giant, fragile snowball being thrown into a roaring fire. It doesn't just melt, it can explode into 1,000 tiny pieces. Astronomers observed multiple distinct fragments breaking off from the main nucleus. Initially, 4 main pieces were identified, but soon, dozens more appeared. This suggests a cascading breakup, where the initial fracture led to further destabilization. Each fragment, now smaller and more vulnerable, would have been subject to the same relentless solar assault. The solar wind, a stream of charged particles constantly flowing from the Sun, would also have played a role, pushing and eroding the smaller pieces. To put it mildly, the forces at play near the Sun are immense, and an interstellar object, having traveled through the frigid vacuum of space for millions, if not billions of years, might be particularly susceptible to our Sun's intense environment. But not all things are what they seem. While solar heating is a strong candidate, some aspects of 3I Atlas's behavior were puzzling. Most comets, even those that break up, leave behind a trail of debris that can be observed for weeks or even months. Yet, 3I Atlas's fragments seemed to vanish almost entirely. This led to speculation about its composition. Could this interstellar visitor have been unusually fragile? Perhaps its interior was far less cohesive than typical solar system comets. If it was made of very loose, fluffy material, almost like cotton candy, then even small amounts of solar energy could have quickly vaporized it or dispersed its components into microscopic dust motes, too small for even the most powerful telescopes to detect. This would mean a truly exotic composition, a wow factor that offers a glimpse into how comets might form in other star systems, potentially very differently from our own. What many overlooked is the possibility of supervolatiles. These are extremely volatile substances, like frozen nitrogen or carbon monoxide, which turn directly from solid to gas at very low temperatures. If 3I Atlas contained a significant amount of these supervolatiles, then as it warmed, they would have erupted violently, tearing the comet apart from the inside out. Such a rapid release of gas would not only fragment the nucleus, but could also accelerate the smaller pieces away from each other, dispersing them quickly. And you can see this everywhere when we talk about energy. A sudden release can be incredibly destructive. This scenario, while less common for comets from our own solar system, is a fascinating prospect for an interstellar visitor. It hints that the conditions in its home stellar nursery might have been drastically different, allowing for the incorporation of such icy components. The complete disappearance, however, remains the biggest head-scratcher. Even if it broke into tiny dust particles, the collective mass of these particles should still reflect some sunlight. The fact that even the most sensitive instruments lost all trace suggests something more profound. Could it be that the particles were dispersed so widely across millions of miles that their combined light was simply too faint to register? Or did the material somehow undergo a chemical transformation, becoming transparent or non-reflective to our instruments? The mystery endures, leaving astronomers to ponder if 3I Atlas was a type of cometary phenomenon we simply haven't encountered or understood yet. The lingering questions about its fate continue to haunt astronomers. The cosmic CSI. With 3I Atlas having performed its dramatic vanishing act, the scientific community embarked on a kind of cosmic crime scene investigation. What many overlooked is that even when an object disappears, it leaves behind indirect clues. astronomers meticulously analyzed every scrap of data collected before its demise. They studied its light curve, which showed how its brightness changed over time. They examined its spectral signatures, looking for clues about its chemical makeup. And they scrutinized its trajectory to understand the forces acting upon it. This wasn't just about finding the comet. It was about understanding the fundamental properties of interstellar objects. One line of inquiry focused on its initial appearance. 3I Atlas was initially classified as an asteroid because it didn't immediately show cometary activity. It was only later that a faint coma developed. This suggests that its volatile materials, the icy components, might have been buried deeper beneath a crust of more resilient material. If this crust was thin or uneven, then certain areas might have heated up faster, leading to explosive outbursts that initiated the breakup. Imagine a chocolate shell with a gooey center. Too much heat, and it can burst. This initial asteroid-like behavior, contrasted with its later cometary activity, is a key piece of the puzzle. The thing nobody tells you is that such a dual nature hints at a complex thermal history, perhaps from its journey across the galaxy. Another critical area of investigation involved comparing 3I Atlas to other comets, both interstellar and from our own solar system. While Oumuamua, the first interstellar object, showed no cometary activity, 2I/Borisov, the second, was a classic comet, displaying a clear coma and tail. 3I Atlas seemed to fall somewhere in between, initially inert, then exhibiting activity, and finally disintegrating in an unprecedented manner. This variability among interstellar objects is a wow factor in itself. It tells us that interstellar space isn't just populated by one type of object, but a diverse menagerie of celestial bodies, each with its own unique story and composition. Perhaps 3I Atlas was simply an outlier, an extreme case of a fragile comet. The hunt for any residual dust or gas continued long after the main fragments were gone. Powerful telescopes, equipped with sensitive detectors, performed deep surveys of the region where 3I Atlas was last seen. They searched for faint glows, for subtle shifts in background starlight, anything that could indicate a lingering cloud of debris. However, these searches yielded little to nothing. This really highlighted the completeness of its disappearance. You see, even if it had vaporized, the gases would take time to disperse completely. The lack of any detectable signature strongly suggests that the material either became incredibly diffuse very quickly, or underwent a transformation that made it invisible to our current technology. And you can see this everywhere in science. When something defies our instruments, it often points to a new phenomenon. What if, some scientists pondered, there was something else at play? Could a truly dark, non-reflective object, perhaps even a dark comet, be responsible? While speculative, such ideas arise when conventional explanations fall short. This concept suggests a comet composed predominantly of dark, organic materials and minimal reflective ice, making it incredibly difficult to spot even under direct sunlight. However, for 3I Atlas, we did see it initially, which makes this specific theory less likely. The most shocking fact is that even with all our advanced instruments, the universe still holds secrets that can completely stump us, leaving us with more questions than answers about these enigmatic interstellar visitors. The answers to these perplexing questions might reshape our understanding of cosmic travelers, an alien history. The tale of 3I Atlas isn't just about a missing comet. It's a profound narrative about the vast, dynamic nature of our galaxy. This object originated from another star system, having embarked on a journey across interstellar space for millions, if not billions, of years. Imagine the sheer scale of such a voyage. Traveling tens of thousands of light years, dodging stars and nebulae, enduring the bitter cold and vacuum of the void, only to briefly encounter our sun before its dramatic disintegration. The thing nobody tells you is that each interstellar visitor, no matter how brief its stay, offers an unprecedented window into the stellar nurseries and planetary formation processes around other stars. Prior to 3I Atlas, Oumuamua had already challenged our assumptions about interstellar objects. Its cigar-like shape and unexpected acceleration led to wild speculation, even prompting some to consider an artificial origin, though that theory has largely been debunked. 2I/Borisov, on the other hand, was a more normal comet, hinting that other star systems produce icy bodies similar to our own. The disappearance of 3I Atlas now adds another layer of complexity. It tells us that the diversity of objects in interstellar space is far greater than we might have imagined, encompassing everything from rocky, asteroid-like bodies to fragile, super-volatile rich comets. What many overlooked is the opportunity to study the composition of 3I Atlas even in its brief moment of visibility. Spectroscopic analysis, a technique that breaks down light into its constituent colors, revealed the presence of specific elements and molecules. These spectral fingerprints are like chemical tags, telling us what the comet was made of. While the data was limited due to its breakup, it still offered clues about the building blocks of another star system. The disappearance of 3I Atlas left us with more questions than answers. Do you think we'll ever truly understand what happened? Drop a comment below, hit that like button, and subscribe for more cosmic mysteries.